So in this unit, we're going to be studying things called rational expressions. And rational expressions are any kind of fraction that has a numerator and denominator that are polynomials. So we can see a couple of examples here. 1 over x, m over m plus 1, y squared minus 1 over y squared plus 2y plus 1, and so on. So as long as it's a fraction and as long as we have polynomials, we have a rational expression. What we're going to talk about at first is things that are called non-permissible values. Now, this relates because we are dealing with fractions. We can't not have a 0 in the bottom of a fraction. And because we're dealing with polynomials, with variables, depending on what number we substitute in for the variable, the bottom of the fraction could work out to 0. So we need to take these into account and we need to find them. So to find all of the non-permissible values, what we simply do is we take the denominator and we find what will make it equal to 0. Now we have a couple of different situations here. In A, we have multiple variables, and what we're going to do in this situation is we're just going to split that and separate each variable into its own equation. And then we need to solve each one. So on the left we have 4s equals 0, divide both sides by 4, and we get that s equals 0 is one non-permissible value. Likewise, on r squared equals 0, we'll have to square root both sides, and we end up with r equals 0 being a non-permissible value. B, same process. We take the denominator, we make it equal 0, and now because we're down to one variable, the method does change somewhat, but not much yet. We have this already factored out. This x has been taken out as a common factor. So because of that, we can split just as we would with solving a quadratic equation. So on the left we have x equals 0. That's already solved. That's fine. On the right we do need to do a little bit of work. We'll add 3 to both sides, get 2x equals 3. Divide both sides by 2, and instead of converting that to a decimal, we'll leave it as a fraction, and x equals 3 over 2 is non-permissible. C, again, same process. We'll take the denominator, we'll make it equal 0. But we can't go straight to splitting this up in C. We actually need to factor this equation in order to be able to solve it. So with A and B, they had already been factored or were not factorable. With C, because we have multiple terms, we do need to factor it. So to factor this, we need two numbers that both multiply to negative 12 and also add to negative 1. That would be negative 4 and 3. Once we factor it, we can split it. So we have p minus 4 equals 0 and p plus 3 equals 0. On the left, we'll add 4 and we get p equals 4 as a non-permissible value. On the right, we'll subtract 3 and get p equals negative 3.